Student, today we are going to discuss some examples on degeneracy of transportation problem. So degeneracy of transportation problem is here if degeneracy of transportation problem. Okay, so their definition is if in feasible solution number of allocation is less than m plus n minus 1, that is m is the number of rows, n is the number of columns minus 1. Okay, so in given problem, if number of allocations are less than m plus n minus 1, then we say that given problem is a degenerate transportation problem. And how to solve this degeneracy problem? There are two steps at the initial stage, means after finding VAM method, NWCM method, or LCM method, okay, least cost method. So if allocations are less than m plus n minus 1, then we have to introduce artificial quantity epsilon. Okay, then we have to introduce artificial quantity epsilon in one or more unoccupied cell. That is, if m plus n minus 1, how many allocations are required depends on number of allocations are required. Okay, so if one allocation is required for m plus n minus 1 allocation, then we introduce one epsilon. And how to choose this epsilon? We this epsilon to introduce a very small quantity. Okay, in given column unoccupied cell, choose the unoccupied cell which is very small quantity and assign it to be 0 when actual used in calculation. That is, in actual calculation this epsilon is a very small quantity, and we choose in calculation take their value is equal to 0 after finding total cost. Okay, and second is degeneracy occurs during the test of Modi method. Okay, degeneracy occurs during test of Modi method. If firstly given transportation problem, finding three methods, one NWCM, VAM, and LCM, and then number of allocation is equal to m plus n, and then we have to find the Modi method, that is optimal solution obtained. Optimal solution we have to finding, then optimal solution we apply Modi method. Okay, after in Modi method, if number of allocation are less than m plus n minus 1, means after introducing closed loop, and then we are allocating the all cells. Okay, then introduce epsilon any one of these. Okay, so there are steps for degeneracy. This is a among the empty cell we choose any empty cell having the least cost. Okay, so choose any least cost in unoccupied cell which is an independent position. Okay, their position is not fixed. So if such cell more than one or one, then choose any one of these. Okay, so smallest element in given transportation problem are more than one, then choose any one of these. Okay, and allocate the small positive quantity epsilon greater than 0 in that cell. Okay, so this is our algorithm not but degeneracy of transportation problem. So example is here, take example. Find initial basic feasible solution. Your example. Find initial basic feasible solution of optimal transportation of find initial basic feasible solution and optimal solution. Okay, and optimal solution of given transportation problem. Given transportation problem Here problem is given that D1, D2, D3 and D4. Here S1, S2 and S3. Okay, S1, S2 and S3. Here 1, 2, 3, 4. Then 4, 3, 2, 0. 4, 3, 2, 0. Then 0, 2, 2, 1. 0, 2, 2, 1. This problem is given, and here allocations are also given. That here allocations are 2 has allocation is 6. Then here 2 has allocation is 2. Then this 2 has allocation is 6. Then 0 has allocation is 6, and 0 here 0 has allocation is 4. Okay, so this problem is directly given with allocation. Okay, here there is no need to find the initial basic feasible solution by NWCM, LCM or wave method. Okay, here allocations are directly given. So firstly we have to check that number of allocation is equal to m plus n minus 1 or not. Here number of allocations, here number of allocations here 1, 2, 3, 4, 5. Okay, number of allocation is equal to 5, and here number of columns plus number of rows is equal to 7 minus 1, which is not equal to m plus n minus 1. That is given problem is a degeneracy problem. Okay, it is a degeneracy problem. Then how to find degeneracy problem? We have to solve the degeneracy problem by introducing very small quantity epsilon in transportation table. Very small quantity introducing in for epsilon. Okay, so how to take epsilon, what quantity taking epsilon in given problem. So for introducing epsilon, choose the smallest quantity in given transportation problem. Okay, that is least cost. Take a least cost in a given transportation problem. So here smallest quantity is here 1 and here 1. Okay, choose any one of these. If we choosing any one of these, take their allocate their epsilon. Okay, and if after allocating their epsilon, the minimum cost of unoccupied cell is here epsilon, and then find their total cost. Okay, that is we have to use Moody method to solve optimal solution. Okay, so here to solve the degeneracy problem, we introduce of a very small quantity epsilon in transportation table, so that we get a number of allocation is equal to m plus n minus 1. Why epsilon is allocating in given problem? Because we get a number of allocation is equal to m plus n minus 1. Here minimum cost in given transportation problem for unoccupied cell. Minimum cost is here 1. Okay, here minimum cost among all unoccupied cell is here unoccupied cell is 1. Okay, here 1 is a two values are here given, that two position is one is given. Select any one of this. If we here I am selecting this S1 D1. Okay, therefore allocate epsilon to the cost 1. Okay, to the cost 1, and write table again here D1 D2 D3 D4, here S1 S2 and S3. so here 1 take their allocation is epsilon. Okay, then 2 has value 6, then other allocation write as it is. So here 4 3, 2 has 2 and 0 has 6 allocation, then 0 has 4 allocation and 1. Okay, in this way. And here after allocating, number of allocation is equal to 1 2 3 4 5 6. Number of allocation is equal to, now here number of allocation is equal to m plus n minus 1, and therefore now we have to find the uj and vj by using Cij is equal to ui plus vj for occupied cell. Okay, now to find optimal solution. Optimal solution for occupied cell. We have to calculate what calculate here. We have to calculate ui and vj by using Cij is equal to ui plus vj. Okay, and therefore first occupied cell is C11 is equal to C11, their value is 1, is equal to u1 plus v1. Then C12 is equal to, their value is 2. Okay, their value is 2, and 2 is equal to u1 plus v2. Then next allocation is C23, their value is 2, is equal to u2 plus v3. Then next is fourth number. Okay, C24 is equal to 0, their value is u2 plus v4. Then next is C31, third row first column. C31, their value is also 0, put their value is u3 plus v1, and then last is C33, their value is 2, is equal to u3 plus v3. Okay, so here in each column number of all allocations are same, 2 2 2. Okay, put any one of this here 0, and then find other values. Okay, if we putting here u1 equal to 0. Okay, put u1 equal to 0, then here v1 equal to 1. If we putting u1 is equal to 0, then v1 is equal to 1. Then v2 also is equal to 2. Then value of v2 is find here, and v1 is also find. Then v1 and u3. Okay, if we putting v1 is equal to 1, then u3 is equal to minus 1. Okay, minus 1. Then u3 is equal to minus 1. Then v3, value of v3 is 3. Okay, value of v3 is equal to 3. If we putting u3 is equal to minus 1, the value of v3 is equal to 3, and value of v3 is equal to 3. Then value of u2 is equal to minus 1. Value of u2 is equal to minus 1. Okay, and value of u2 is equal to minus 1. Then value of v4 is equal to 1. Then v4 is equal to 1. So here all values are 100. That is u1 is equal to 0, u2 is equal to minus 1, u3 is equal to minus 1, u3 is equal to minus 1. Then v1 is equal to 1, v1 is equal to 1, v2 is equal to 2, v3 is equal to 3, 1 2 3 1, 1 2 3 1. Okay, 1 2 3 1, and u1 u2 are 0 minus 1. Okay, so now we have to find the, now for unoccupied cell we have to calculate delta ij. Unoccupied cells we have to calculate delta ij is equal to Cij minus ui plus vj. Okay, so unoccupied cells are third and fourth, first row, third column and fourth column. So delta 13 is equal to C13 minus u1 plus v3. So put their values. C13 is here 3. Okay, 3 minus u1 is 0 plus v3 is 3. 3 minus 3 is equal to 0. Okay, then next is delta 14. Delta 14 is C14 minus u1 plus v4, and C14 their value is 4 minus u1 value 0 plus v4 value is 1, their value is 3. Okay, then delta 21, then delta 21 is equal to C21 minus u2 plus v1 is equal to C21 has value is 4 minus C21 has value is 4 minus u2 is minus 1 plus v1 is 1 minus 1 plus 1 0, remaining only 4. Okay, then delta 22 is equal to C22 minus u2 plus v2, so C22 is a 3 minus u2, value of u2 is minus 1 plus v2 is 2, so 3 minus 1 is equal to 2. Then next delta 32 is equal to C32 minus u3 plus v2. C32 is value is 2 minus u3 value is minus 1 and v2 value is 2, so 2 minus 1 is 1. Then last one is delta 34 is equal to C34 minus u3 plus v4 is equal to C34 is 1 minus u3 has value is minus 1 plus v4 has value is 1, so remaining only 1. Here all delta i's are greater than 0. Okay, so therefore here all delta ij are greater or equal 0. Okay, here all delta ij are greater or equal 0. Therefore by algorithm Modi method optimal solution is obtained. Okay, here all delta ij are greater or equal 0, and therefore optimal solution here optimal solution is obtained. Optimal solution is obtained. Here optimal solution is obtained. Here another one condition is again alternative optimal solution. Okay, in degeneracy alternative optimal solution. So alternative optimal solution means if one of the delta ij is equal to 0, an alternative optimal solution can be obtained with another set of allocation without increasing total transportation cost. Okay, that is allocation set. Here allocation set is here this 1 2 3 1 2 2 0. This is allocation set, and another also allocation set is exist. Okay, this one is allocation set and another is also allocation set is exist. Then we say that given problem has alternative optimal solution. Okay, so and their cost is same for both allocation, for both set of allocation their cost is same. So if in unoccupied cell has delta Ig is equal to 0, so here delta Ig is equal to 0 for first 1 3 cell. Okay, so delta Ig is 0, and so it has alternative optimal solution, and one alternative optimal solution is here, but here delta 1 3 is equal to 0, therefore which has alternative solution, that is alternative or multiple solution, alternative optimal solution. Okay, and one of its solution is total cost is equal to 1 into epsilon plus 2 into 6 plus 2 into 2 plus 0 into 6, 2 into 2 plus 0 into 6 plus 0 into 4 plus 2 into 6, 0 into 4 plus 2 into 6, and so their value is epsilon plus 12 plus 4 plus 12, so their value is epsilon plus 28. Okay, but in actual calculation we treat epsilon as a very small quantity and assign it to be 0. That is, here epsilon is a very small quantity, that is which is near to 0, and so put epsilon equal to 0, and therefore total cost is equal to 28. Okay, this is one solution. And another solution, if we find another solution of given alternative solution, okay, then we have to start the loop at 1 3. Okay, take a loop at cell 1 3 and then find the next allocation. Okay, so and here adding here one another point, another alternative solution is okay, so delta 1 3 is 0, delta 1 3 is equal to 0, then take a loop, or here taking loop we draw close path, or we draw close loop from cell what cell 1 3. Okay, from cell 1 3, here 1 3 cell, how to close loop, here close loop is does not exist. Okay, here close loop does not exist in for this cell because their value is delta 1 3 has, okay, close loop is exist delta 1 3, here this is a closed loop. Okay, so writing this closed loop 1 2 3 4, then next values are 4 3 2 0, 4 3 2 0, then next is 0 2 2 1, 0 2 2 1. Okay, and so allocation here epsilon 2 has value is 6, then 2 has value is 2, 0 has value is 6, then here 0 has value is 4, and then last one is 2 has value is 6, their value is 6. Okay, so closed loop from 1 3 cell is this is first row s1 s2 s3 d1 d2 d3 and d4 1 3 first row second third column. So we have to starting here here closed loop in this way. This is a one allocated cell at corner, then this is second corner, okay, then this is third corner, and last one is fourth corner. Okay, in this way this is our closed loop. Okay, and here positive sign for starting cell, then next is alternative sign. Okay, plus minus plus minus plus minus plus minus is here. Then for negative sign smallest allocation is here for negative 6. Okay, 6 or epsilon. Here epsilon is a very small quantity also. So if we taking epsilon, then number of allocation is equal to this is 0, and other all here again epsilon. Okay, so here epsilon is very small quantity, epsilon is very small quantity for negative sign. Okay, and therefore add epsilon where there positive sign, and subtract epsilon where there negative sign. Okay, so therefore next path is next transportation table is here 1 2 3 4, then 4 3 2 0, then 0 2 2 1. Okay, so here adding epsilon, here 6 minus epsilon, then here 2 as it is, then 6 as it is. So here 6 minus epsilon here, so here not any one value, here epsilon minus epsilon is 0, so neglecting this, and then 4 has 4 plus epsilon here adding. In another example alternative, here epsilon is very small quantity, so another example epsilon is deleting. Okay, therefore here this is our, then any one of the alternative solution, so their cost is, therefore total cost is equal to 2 into 6 plus 3 into epsilon plus 2 into 2 plus 0 into 6 plus 0 into 4 plus epsilon plus 2 into 6 minus epsilon. So their value is 12 plus 3 epsilon, 12 plus 3 epsilon plus 4, then here 12 minus 2 epsilon, so their value is 12 24 plus 4 28, 3 epsilon minus 2 epsilon is epsilon, so epsilon put epsilon equal to 0, put epsilon is equal to 0, we get total cost is equal to 28. Okay, so this is a definition of alternative solution means delta ij is equal to 0, and alternative optimum solution can be obtained with another set of allocation. Here two sets exist for to this cost. Here set for here 1 to means this order, this set is a S1 D1, S1 D1, then S1 D2, then S2 D3, then S2 D4, then S3 D1 and S3 D3. This set is exist. This is a set of allocation set, and another set is exist here. Another set is exist here. This set is S2 D2, then sorry S1 D2, then S1 D3. Okay, this value changes, and another set is as it is. Okay, so this is a two sets are exist in given problem. So this given problem has a alternative solution. How to find alternative degenerate solution? Okay.